Okay, it is high time for a little update video on that Keytek CTS-5000 project. I already made 2 videos about it quite a long while ago. So yeah, it's really high time for another update video. So this is just gonna be me recording my screen because I want to take a look at the ROM disassembly and decompile. It's far from finished yet. Actually, I haven't touched it in the past 5 months or so, but I do want to get back into it once I'm done with the Elka. Because, this piano or synthesizer, that's what basically is really cool. And the Keytek synths in general, I think, are really cool. The most well-known of the Keytek series is the CTS-5000. So here you go. This is the CTS-5000, which is a digital synthesizer with some analog filters and stuff. And the CTS-5000, which I have 2 of, is basically the digital piano version of that with a wonderful, wonderful keypad. This keypad is probably the best I've ever played, but that aside, the synthesis method in this piano is the same used as the synthesis method in the synthesizer. Now there's 2 chips in the Keytek synthesizers, the M114, and there's 2 of those. And these chips are responsible for the synthesis. Basically what they do is they take 3 samples of, well, for example, a piano, and they crossfade between those 3 samples. And the actual crossfading is controlled by envelopes or by a microprocessor, in this case, which is one over here, which is the 68HT11. And you can just arbitrarily crossfade between those 3 samples, and you can do all sorts of funky things. So what I want to do in this video, and this is kind of going to be a recap for myself as well, so it's it's probably not gonna go as smooth as I like it to be, but it will. That's how we roll, huh? I have 4 things open here. I have a photo of the main board to the right here, and the synthesizer board to the left. There's a few other boards like the front panel and the equalizer and some other things. But this is the heart of the Keytek synthesizer. This is where almost all of the magic happens. So naturally, I wanted to tackle this first. Now, what I did is, as you can see, I labeled all the ICs so I can follow traces and see where they lead to and what connects to what. There is a mystery chip here, which I don't really remember what it did. I don't think I figured this one out yet. But I think it had something to do with scanning the keyboard, which should be connected down here. It might actually be like a custom job or a coprocessor of sorts, because the keyboard is velocity sensitive, and frankly, this 6800 processor is a little bit underpowered for everything it needs to do. Because this thing is responsible for handling MIDI, it's responsible for handling the front panel, controlling all that, scanning the buttons. There's also a coprocessor on the front panel, which handles the 7-segment display. But yeah, this still needs to do a lot. It generates envelopes and LFOs to modulate the crossfading and other things of the synthesizer chips. There's also things like vibrato and detuning and all sorts of things. It handles the equalizer. So yeah, there's a lot going on in this microprocessor. So yeah, I have just the physical boards on my table, so I can use my multimeter and a magnifying glass to trace out everything. And what I do with that is I make a schematic, of course. So Of course, this is still very unfinished, but here is a part of the main board. We have the microprocessor over here, the 68HE11. Two ports are used for the address and data buses. Port C is both data as the lower address bus, so that's multiplexed. That connects to a bunch of buffers, as you can see here, which switch in. They're mostly responsible for switching in between the data and the address, because it needs to access the RAM and the ROM, of course. So here's our mystery chip. No clue what this is. It does connect to the interrupt IRQ over here. So what this exactly does, I'll have to see in the disassembly and the C code I'm making. So over here we have what looks like a DAC. Yes, this I believe this was a DAC. This probably controls the tremolo, which is a SEM chip, a Curtis chip. So that of course needs an analog control voltage. So there's a little resistor ladder. I couldn't find the right symbol. Yeah, there's no R2R symbol in Keytek apparently, which is kind of weird, but okay. But yeah, that's an R2R ladder, which goes through an op-amp buffer and then goes to various other parts. There's some more buffer control logic that goes to the synth board, which and also has connections to the synth board. Uses a serial peripheral interface, so that's probably used to interface with the synthesizer part. Probably gonna guess it actually connects to the equalizer. So speaking of the equalizer, there's also 7 sliders for the EQ on the front panel. And those seem to be demultiplexed to here. And I'm going to guess these were the ADC ports. So yeah, there's something going on with the sliders. They're probably being read out in this circuit, but I don't exactly remember how it worked. Like I said, I haven't touched this in 5 months. So. Anyways, to the left of the equalizer I/O, there is of course the MIDI. And that's very straightforward MIDI. We have MIDI in, then to an optocoupler, and it goes through serial RX and serial TX. Goes through a buffer, no, 2 buffers actually. And then to MIDI out, so that's super cookie cutter MIDI implementation. Furthermore, at the top right here, so here's a whole bunch of front panel buttons and display stuff going on. Here we have the main control IC, which is responsible for controlling the 7-segment displays. Basically, just it scans through all the 7-segment displays, and it will turn on the right LEDs at the right time, so you actually get numbers on there. And of course, there's some control logic associated with that. Over here, here's the connector. So I put them just side by side here, so it's a little bit easier to see what connects to what, while also still having the actual connector in there to make it less confusing. So I actually know that this is separate on another PCB than this part. So that's why this is kind of funky, but yeah, this works for me. And yeah, then there's of course a whole bunch of buttons which are arranged in a 3x6 matrix. Okay. And that's matrix connects to, looks like PA0 to PA4. And probably some others as well. So that goes directly to the CPU. So yeah, that's the schematic so far, and that's mostly just so I can figure out what's going on in here, because this is the disassembly. And yeah, that's it's a lot. So this is OPC. This is the entry function. So the main function you'd have in C, and the C code I'll get to in a second. And well, this is basically just all assembly, 6800 assembly. Luckily, IDA Pro makes it a little bit easier to see what's going on because it arranges various functions and statements into separate blocks, and it puts little arrows whenever there's a jump to another address location. And this makes it really easy to identify functions and structure of the software. Yeah, this is a lot. And this is just the main loop, this. As you can see, it keeps going, going, going. And yeah, this is a huge, huge main loop. This is actually the ending of it. So yeah, that is a lot going on. And of course, there's lots of references to other functions in there. Let me see if I can just find where I was. I think over here. Because there's IRQ here, which does a few things. So that's the IRQ in our schematic over here, which connects to the mystery chip. So that's something I really want to figure out. So basically I'm tackling this. I'm just putting comments on every bit of assembly so I can have a bit of a guide as to what is exactly going on. I had to manually label all these memory addresses. I had to figure those out, which was a bit of a pain in the ass. I actually needed the data sheet. I actually needed to grab the data sheet of the 68HC11. I need to know what the various functions of the microprocessor are and in which addresses they are accessible. So that's how I figured out all these, but yeah, it's pretty painful. Of course, we have the ports, port D, port A over here, which corresponds to the ports on here. So here we have port B, C, port A, port E, and port D over here. So yeah, I know if something accesses port D, then yeah, it has something to do with the synth port or the MIDI. Something accesses port A, it's likely to do with its equalizer in the front panel. In fact, the entirety of port A seems to be dedicated to all the front panel functions. So that makes identifying structure a little bit easier. So, but yeah, that's all assembly, which is a bit of a nightmare. So what I'm doing is I'm manually decompiling the assembly to C, which is something a little bit more readable. So of course there's lots of notes and theories as to what is going on. There's some declarations, such as example, the memories I've defined as to arrays to make it a little bit easier to see if like, okay, this is accessing the RAM internally or externally. Address locations and operations defined with these. And of course, there's a whole bunch of defines for all the ports and all the registers and settings that the microprocessor has. And there's a lot going on. So let's just go to the main one. So OPC. Main function is called after reset or watchdog exception. The 68HC11 does have a watchdog function and they are using it. The main function of course starts with setting up all the registers and all the settings and modes of the microprocessor, as well as initializing any external devices such as the synthesizer or the equalizer or the front panel, etc. So it sets some timers, it sets some registers here. It sets an interrupt, the RQ, as we saw, which comes from the mystery chip. It also sets the RQ interrupt priority. It disables this timer, which is on port A. So since port A is used for the front panel controls and for the 7-segment display, of course that needs to be turned off. There's some more timer stuff over here. Now here it seems we have two main timers. Yep. So it looks like the timer is set to output compare, with comparing these two values. And from what I recall, in some of the subroutines, that timer is actually activated and deactivated. Now, I'm not sure what it does, but since this is a synthesizer, and since you have things like envelopes going on, obviously you need consistent timing. So I'm going to guess that that's what the timer is used for. So here we have port D, which is the serial of the MIDI and as well as the synth port. It says the baud rate of the serial port, of course, to the MIDI rate of 31,250. Yay! And then it starts setting up all sorts of other things. Now, there's some confusing things such as this here. It seems to clear the internal RAM for some reason. I'm not sure why. But apparently they needed to, and then they set some values in the RAM. And here's a little interesting thing. I'm not exactly sure what this does yet, but during boot up, so when the main function runs, it checks if a pin is low. So PA0 and goes to this button. So if we can figure out which button that is that connects to PA0, which I should be able to, then I can figure out what happens when you hold that button, the synthesizer. Maybe it goes into a special mode, because yeah, there's all sorts of stuff happening. I think when you hold the button during boot up, it copies over a whole bunch of memory, and maybe it sets a bunch of parameters on the synthesis board. So maybe it sets certain parameters that allows you to use the synth in the test mode. I don't know. But yeah, that's an interesting little tidbit over here. And yeah, that's basically where I was in the main function. It's and run some subroutines too, which are at the top here. So unknown purpose does stuff with synth boards on port D. So this probably sets either the EQ or it sets the synth chips to certain modes and settings, or maybe it writes the envelopes. I don't know yet. Here's an unknown function. This has possibly things to do with the display. So this might be a function that writes a certain number to the display. I don't know yet. Okay, so there is certain sections in the ROM which look like this. And these look suspiciously a lot like preset values, hard-coded waveforms, or perhaps envelopes. Maybe there's an exponential conversion table in here. Those things are often used in synthesizers. So there's quite a few of these sections which just have data. So, and it seems that this function actually does something with some of those addresses which hold data. But again, I don't know yet what. Now this function writes data to the front panel display controller. And then it writes serial data to this control chip, which uses a serial interface, data and clock over here, which is connected to PA4 and PA3. And yeah, PA4 and PA3 are used a lot in this subroutine. And that's kind of what I'm doing now with the CTS-5000, just trying to figure out how it works, what does what. Now, of course, this C code isn't designed to be compiled, and I'm not writing this to be correct. I'm just writing this to be understandable, so I can understand what is going on in, well, this mess. And then ultimately, I'll have C pseudocode, which should be entirely correct. And then I can write proper C code, which again is going to be a lot of work, which I'm going to try to compile, put on a new EEPROM, and put in the synth. And then hopefully it will run properly. Hopefully. But it's still going to be a lot of work, and yeah, it's probably going to be, I don't know, another year or so before I even reach that point. At the moment, this is very much a side project. But I do want to continue it because I really want to, well, first of all, this is mostly an educational project for myself. So I can learn assembly a little bit better to understand how it works, even though it isn't x86 or x64 assembly, and rather a more outdated form of assembly. Well, usually it's kind of same shit, different diaper with programming. And this gives a lot of insight onto how to write assembly, as well as to disassemble it and decompile things. Gives me a lot of insight in how microprocessors or processors in general do things, and how high-level programming languages like C and C++ translate to assembly. And yeah, maybe release a firmware update for this thing. Sounds completely insane, to be honest. Like, why? Why would anyone do this? What's wrong with me? But you know what? Hey, I'm having fun, so, and that's all that counts, really. So yeah, that's a little bit of insight in the project that is the CTS-5000. And yeah, I wanna learn more about it. So anyways, that was a bit of a rambly video. I hope it was enjoyable nonetheless. I hope it has given some insight into the inner workings of the Keytek. Well, so far anyways, and in my process. If you have any tips or tricks that would help me with this project, they are more than welcome. Because this is a lot to take in for one person, honestly. Yeah, and well, hey, maybe if you want to help out, that would be more than welcome too. I'll be happy to nerd out with others. So, anyways, that was it for this rambly video, and I'll see you guys in the next one. Bye bye.